Hello friends, I welcome you in lecture number 10 on hypothesis testing. In this lecture, we are going to discuss about two sample t-test or small sample test for difference of means. So far, we have discussed about two sample z-test, or if we have large samples, that is, if we have two samples of size n1 and n2 which are greater than or equal to 30, then we can apply two sample z test, and the z statistic which we have discussed is z equal to x bar minus y bar minus mu1 minus mu2 divided by square root of sigma 1 square over n1 plus sigma 2 square over n2. And if we assume that our null hypothesis is that two population means are equal, then this quantity will be considered as 0, and we will test this null hypothesis using this two sample z test if we have large sample. So this is called large sample test for difference of two means, or simply we can call this as two sample z test. Now question arises, what happens if sample sizes are not bigger than 30? Suppose we have two samples of sizes which are less than 30. So in that case we cannot apply this two sample z test. For that we have to go for two sample t test. Now for applying two sample t test, we have to add one more assumption. For applying two sample z test, if you recall, we have made certain assumptions. First assumption was that our samples are random samples. We are considering random sampling. Second assumption was that they are independent samples, or observations in each of the sample are not dependent on each other. So we have two assumptions. First sample is a random sample, second sample is also a random sample, and another assumption is they are independent of each other, and also we consider large samples. So under these conditions we can apply two sample z test. Now for two sample t test, we have to add one more assumption, that the populations which we are considering, or the samples which we are considering from the populations, so those two populations must follow normal distribution, or we can say that population distributions must be normal, or the populations from which we are drawing samples, they must be normal. And if our sample size is small, that is less than 30, then under this assumption, together with all these assumptions are always there for two sample z test or two sample t test. So with these assumptions we are adding one more assumption, that the populations must follow normal distribution. So if these assumptions are satisfied, then we can go for applying two sample t test. Now for two sample t test also we are considering two cases. First case is that the populations from which we are drawing samples, they have equal variances. If sigma 1 is the standard deviation of population 1 and sigma 2 is the standard deviation of population 2, then these are the variances of both the populations. So there are two possibilities, either we have equal population variances or we have different population variances. In both the cases we have different methods. So first we are discussing that what is two sample t test if we have equal population variances, and this we will discuss after this case. So now we focus on this case that what is two sample t-test in the case of equal population variances, and this assumption is always there for both the cases, that underlying populations are normal. Now suppose we have equal population variances. Suppose sigma 1 square is the variance of population 1 and sigma 2 square is the variance of population 2, and suppose both are equal to some common value, say sigma square. So what is two sample t-test in the case of equal population variances? And we only know that both the populations have equal variances, but variances are unknown. This common value we don't know. So what we are given? So we are given that we have two samples of sizes n1 and n2 from two normal populations. We are given the corresponding means for those two samples, that is x bar is the mean of sample 1, y bar is the mean of sample 2, and we are given values of standard deviations of both the samples. So this is given information, and we assume that population variances are equal. So in this situation our t statistic looks like this. It is similar to z statistics. Here we are considering difference of two sample means. Here we consider difference of two population means, and here we have S1 square. In the z test we are considering this quantity. Suppose we are writing as two sample z test, then this is the formula for two sample z test. But we want to write formula for t statistic, and here I have written first for two sample z test. I have just written this formula, that z is given by this. Now what is the difference between this formula and t statistic formula? So this is the formula for z statistic, and now we cannot apply z statistic because we have small samples. And what is given? We are given that we have equal population variances. So here I can write sigma square, and I can take sigma square common, and because it is in the square root, here I will have sigma outside this. So here I have 1 over n1 plus 1 over n2. But sigma is also unknown. We don't know what is sigma. We know that two population variances or two population standard deviations are equal, but their equal value is unknown. So what we have to do is, using these two sample standard deviations, we will estimate this population standard deviation. So we have to find out estimated or estimator for population standard deviation, and for that we will combine these two given values of sample standard deviations. So we are combining two sample standard deviations to find out the estimator of this population standard deviation. So that estimator we will denote by S suffix P. P for pooled estimator. Pooled, that means combined estimator of population standard deviation. So how to write down the formula for this combined estimator? This S suffix P is called pooled or combined estimator for population standard deviation, and if we square, then it is called pooled variance for this population variance. So this SP square is the estimator of population variance, or this SP is the estimator of population standard deviation. And you have to consider this formula for pooled estimator. We are using this S1 and S2, and sample sizes are N1 and N2. So in the denominator we will consider N1 plus N2 minus 2. In the numerator we have n1 minus 1, that is sample size minus 1 into variance of first sample. Same thing for another sample, n2 minus 1 into variance of second sample. This is called weighted average of these two sample standard deviations or sample variances. So we have to remember this formula. This is called pooled variance or pooled estimator of population variance. So we will replace this population variance which is unknown by this S suffix P. And if we consider this formula for T statistic, then this T statistics follows a T distribution with degrees of freedom equal to n1 plus n2 minus 2. Whenever we are using T distribution, we have to specify the degrees of freedom. So degrees of freedom is n1 plus n2 minus 2. Formula for T statistic is T equal to x bar minus y bar minus mu1 minus mu2 divided by SP times square root of 1 over n1 plus 1 over n2. What is SP? SP is the pooled or combined estimator of population standard deviation sigma, which is equal for both the populations, and this pooled variance SP square is given by this formula n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. And we are familiar with the formulas of these variances. We know that this variance is given by sigma. Suppose our first sample is x1 x2 up to xn1, then it is given by xi minus mean of first sample, I is from 1 to n1 divided by sample size minus 1. Similarly, s2 square is given by, suppose our second sample is y1 y2 up to y suffix n2, then same formula here, our variable is y, yi minus y bar whole square I equal to 1 to n2 divided by n2 minus 1. So these are the formulas for sample variances which we have discussed in the lecture of basic statistics. So if you can see here, here I have s1 square into n1 minus 1. So if I consider this quantity to the left hand side, then I can replace this n1 minus 1 into s1 square by this summation sigma xi minus x bar whole square. Same thing here, from this we have n2 minus 1 into s2 square, that we can replace by sigma yi minus y bar square. So you can write your pooled variance in this form also. Here I can write n1 minus 1 into s1 square is this summation, n2 minus 1 into s2 square is this summation. So here I can write sigma xi minus x bar whole square I equal to 1 to n1 plus sigma yi minus y bar whole square I equal to 1 to n2 divided by n1 plus n2 minus 2. If you wish, you can use this formula also, both are equivalent. So in this situation, we have to first find out this pooled variance for this population variance, because we will require it to calculate the value of T statistic. So whenever you have problem of two sample T test, you will be given all these values n1, n2, x bar, y bar, s1, s2. So using this information, you can find out this pooled estimator. If your data is given in this form, if you are given observations for both the samples, then you can use this formula. You can just calculate x bar, y bar, and using this formula, you can directly calculate pooled variance. Once you calculate pooled variance, you will be able to decide value of T statistic under the null hypothesis. Here this is going to be 0 because our null hypothesis is mu1 equal to mu2. Using this t-statistic, we will obtain value of using this formula we will obtain value of t-statistic. After that we will check whether our test is two-tailed or one-tailed. If we have one-tailed test, we will calculate T alpha for given level of significance and degrees of freedom. And if we have two-tailed test, we will find out these two critical values using T distribution table with this degrees of freedom. Degrees of freedom is equal to n1 plus n2 minus 2. So all these things I have written systematically here. What we have discussed small sample test for difference of means or two sample t test, and we are assuming that two population variances are equal, that sigma 1 square, sigma 2 square and equal to sigma square. These are the assumptions. First sample is x1 x2 up to xn1, that is it is of size n1 and its mean is denoted by mu1 and variance is denoted by sigma 1 square. Another sample has observations y1 y2 up to yn2 and size is n2, mean is mu2, variance is sigma 2 square. Third assumption is two samples are independent. Fourth assumption is both populations are normal. This is important to apply this t-test because we have small sample sizes. This must be given. If it is not given, we first assume that both the populations are normal, and we are considering the case of equal population variances. Suppose equal population variances have common value sigma square. So under this assumption, statistic for two sample t-test is given by t equal to x bar minus y bar minus difference of two population means divided by sp times square root of 1 over n1 plus 1 over n2, and this has a t distribution with n1 plus n2 minus 2 degrees of freedom, and this sp is nothing but pooled or combined estimator of population standard deviation sigma, which is equal for both the populations, and it is given by these formulas. Sp square equal to sigma xi minus x bar square plus sigma yi minus y bar square divided by n1 plus n2 minus 2, and another form is n1 minus 1 s1 square plus n2 minus 1 s2 square divided by n1 plus n2 minus 2. We will first calculate this pooled variance and then we will calculate value of t statistic. Here we will require this value of s suffix p, and if you are directly given values of this sample variances s1 and s2, then you can use this formula. And if you are given data for two samples, that is you are given observations, then you can use this formula to calculate pooled variance. Because we are using this pooled variance, sometimes this test is also known as pooled variance t-test. It is also sometimes known as pooled variance t-test because we are using pooled estimator of population variance. So this is all about this session. In this session we have discussed that if we have small samples, that is sample sizes are smaller than 30, and if the underlying populations are normal, if we have random and independent samples, and if we assume that two population variances are equal, then we will apply two sample t-test. The formula is easy to remember: difference of two sample means minus difference of two population means divided by pooled standard deviation times square root of 1 over n1 plus 1 over n2, where this pooled variance has the formula n1 minus 1 times s1 square plus n2 minus 1 times s2 square divided by n1 plus n2 minus 2. And if you recall this formula for sample variance, it is sigma xi minus x bar square I equal to 1 to sample size divided by sample size minus 1. Similarly, if we have n2 observations in another sample, then it is given by yi minus y bar square I equal to 1 to n2 divided by sample size minus 1. So, using these formulas for sample variances, we can write another formula for pooled variance as sigma xi minus x bar square plus sigma yi minus y bar square divided by n1 plus n2 minus 1. And this follows a t distribution with n1 plus n2 minus 2 degrees of freedom and with alpha level of significance. So, remember these formulas for t statistic and pooled variance. Using these two formulas with all these assumptions, we will consider problems related to two sample t test from next lecture onwards. Thanks for